Good morning, students. Today we are going to start our next chapter 11, Work and Energy. So in this, first of all, we will study about work. Anything when we push or pull any object, if it moves through a distance s, then we say that work has been done. If we say that work has been done, we say that we push or pull an object and it displaces through a distance s. So our formula for work is W equals to force into distance. That how much force we have applied on that object and how much distance it covers while moving from initial position to final position. Suppose this is an object. I have pushed this object and it moves from this position to this position. Now this object is here. Then the force F is applied on this object and it covers this distance s. Then work done on this object is force into displacement. That's all about work done. So we are having different examples. Work. We are having examples of work in our day-to-day life. For an example, if you are moving a huge rock, suppose it do not moves. Obviously, if we apply force on the rock, it will not move. That means if displacement is not there, then we say that work is not done. Okay, for work to be done, displacement and force both should be there. If one force is there and displacement is not, then we say that work is not done. So expression for work is work done is equals to force into displacement. This is an object. We are applying force on this object and it displaces through a distance s. Then we call it as work done. So formula for work done is force into displacement. Unit of force is Newton and unit of distance is meter. And when we take the unit of work done, it comes out to be Newton meter, or we can call it as joules also. Joule is also a unit of work done. Basically, joule is a unit of energy, but work is also a form of energy. Okay, so the unit for work done is joule or Newton meter. Now define 1 joule. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of force. Like in which object is moving, in that particular direction we have to pull the object. Force and displacement both are in the same direction. Then we said that work is done. So we are doing 11.1 example. A force of 5 Newton is acting on an object. The object is displaced through 2 meter in the direction of force. So we have to calculate work done in this question. Simple formula we have to apply. Work done is equals to force into displacement. Work done is equals to force into displacement. Force is given 5 Newton and displacement is 2 meter. So it comes out to be 10 Newton meter, or we can say 10 joules. 1 joule is very important definition. Expression of work done is very important. Next example, try to do it by yourself. Then next is forms or types of work. So let us consider a situation in which force and the displacement are in same direction. Suppose a baby pulling a toy car parallel to the ground. You can see the figure 11.4. A baby is pulling a car towards herself. So the direction in which force she is applying, the car is also pulled towards her direction only. So force and displacement both are in the same direction. So we can say that this is an example of positive work done. The baby has exerted a force in the direction of displacement of the car. In this situation, the work done will be equal to that of the product of force and displacement. So in such situation, we take work done as positive. Then consider another situation. Consider a situation in which an object is moving with a uniform velocity along a particular direction. Suppose a car is coming obviously on a slow speed. A car or any toy car is coming towards this side, and we are retarding its force by putting something in its distance. Now, like when car touches it, now we are applying the force in opposite direction of the object. In this case, the work done is negative. When we are applying the force from the opposite direction, the work is said to be negative. Consider a situation in which an object is moving with a uniform velocity along a particular direction. Now a retarding force, this force is said to be retarding force, is applied in the opposite direction, that is between the angle of two directions is 180 degree. Both directions, the angle between both the direction is 180 degree. So here the force is negative force and work done is said to be negative. Very easy, very important. So we have discussed two types of work, positive and negative. If a force and displacement both are in the same direction, it is said to be positive work, and if force and displacement both are in opposite direction, it is said to be negative work. Example 11.2. A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. So here a porter is lifting the luggage of 15 kg. So first of all, note down the things. Whenever you are doing a numerical, note down the things whatever is given in the question. 15 kg mass of the object. Then he puts that object from the ground to its head. So distance from the ground to his head is 1.5 meter. We have to calculate work done. The formula for work done is force into displacement, and we know the work formula for force. Formula for force is mass into acceleration. We have studied this in our previous chapter. S will remain as it is. Then here in this case, when the object is going against the gravity, so we take acceleration as acceleration due to gravity and distance s. Then mass is 15, gravity is we can take 10, displacement is 1.5. The answer will comes out to be 225 joules. That's how this numerical is. So that's all for today. Thank you.